Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
Latent heat. And you might remember, I like to use the voice a lot, but latent heat is actually the energy associated with the phase change of water. So in a previous video, we talked about the little phase changes of water that we go through, but let's talk a little bit about the energy that goes into each one of those. All right, now, I'll be honest. I tried to make you a little video of how the phase changes, but I got to tell you, there is really nothing more boring than watching water boil. So here we go. Let's talk a little bit about it instead. So let's remember that we do have our water in 3 different phases. We're going to start over here as a solid. This is ice. And we're going to say that ice is at 0 degrees Celsius. Now, as we go through, we're going to be talking about the calories that are involved and the energy that needs to go into changing each one of those phases. But let's remember that we're talking about, with those calories, 1 tiny little cubic centimeter of ice or water or whatever it might be. That's about a centimeter cubed. So how much energy is going to be going into that? Cool. So we're going to have our solid, and then we want to go over to liquid. We got the colors. Let's play with them. Liquid. And that's going to be water. Okay. And I'm going to also put that at 0 degrees because there's going to be a change from solid to liquid. There's going to be that phase change that we start to see. All right. Then we move into our next one, which is going to be liquid, except, and that's also water, except this time it's at 100 degrees Celsius, degrees Celsius. Cool. All right. Now, the last one that we want to take a look at is going to be vapor. And that water vapor is going to be a gas. I suppose we should put that above there, and we call it vapor. And this one we're also going to be putting at 100 degrees Celsius. Okay? So we have some phase changes, solid to liquid, and then we have this time where we're changing the temperature of our actual liquid. Right? And then we have liquid to a vapor. Now, what we know about the metric system is we know that 0 is going to be the spot where it changes from solid to liquid, and 100 degrees is going to be where liquid and gas, where they jump back and forth from each other as well. Okay. Now, in order to change our 1 gram of water, let's see, that would be 1 cubic centimeter, or it's going to be 1 cc, or it's going to be 1 gram, or 1 milliliter, ml, good, 1 milliliter of water. As we're going through and we're increasing the temperature of 1 gram of water by 1 degree Celsius, we need to add 1 calorie. Okay? And so we're going to start measuring in calories. So in order to increase our temperature of our water, we're going to go from 0 to 100. We need to add 100 calories in order to get it go from one to the other. Now, if we're going to be going the other direction, then we're going to be releasing those calories. So we're going to be going from here, and it's going to be minus 100 calories. And we're going to come back over to here. Now, this phase right in here where we can feel the difference, where we can see the difference in temperature, that's referred to as sensible heat. Sensible heat. Okay. I like to think of it like I can sense it, I can feel it. Okay? And that's going to be my sensible heat. Good. Now, the next thing that I need to think about, though, is how do I get my solid to a liquid, or my liquid to a vapor, or vapor to liquid? That's those phase changes. And that's where we're going to be looking at latent heat, the energy associated with the phase change of water. So let's take a look at these guys. Over here, we're going to have some latent heat. That's going to be a phase change of water. Over here, we also have latent heat, because we're going to have to change back and forth. So if we have, let's start here. We have our liquid water and we want it to go to vapor. We're going to need to add energy to it to get it to evaporate. Okay? As a matter of fact, for our 1 little cubic centimeter of water, we actually need to add a ton of energy. What we're going to need to do is we're going to need to add 540 calories in order to get the small little molecules that are in here, the small little water molecules. They've got little hydrogen bonds. They want to stay with their friends. And so in order to make them so excited that they finally will let go, we have to add 540 calories. Okay? It's not changed the physical temperature. It's only changed that phase. Okay, now the other thing that we have is if we are going to be going to water vapor, when it goes back to water, it's releasing again that 540 calories. So we're going to go minus 540 calories for that process to go that way as well. So yes, for evaporation and condensation, we have 540 calories for there. All right, let's come back over here now and think a little bit about what we have going on between our solid and our liquid. If I've got ice and I want it to go to, a solid, it needs to absorb a lot of heat energy. And that heat energy right now, it's pulling it out of my hand and it's making it sting a little bit. Okay? It's going to be pulling that heat energy, and then eventually, finally, it's going to be turning into liquid water. Okay, so how much energy is required to do that change? Again, for my tiny little cubic centimeter of ice, if you will, it's going to be a slightly different size because it's frozen, right? It's expanded just a little bit. From solid to liquid, this one, I need to add 80 calories to get it to change phase. And the same thing's going to be true when we go from liquid to a solid. It's going to be releasing 80 calories. Okay, now here's what's important to understand. That I might have my water, and here we'll make a little beaker here full of water. Okay, and if I am going to be adding energy to that water, for example, to change the temperature, then what I also need to keep in mind is that everything outside of that water, we're going to call this generally the environment. Now in the kitchen, that environment might be on my stove. But if energy is going to be going into that water, if it's going to require that it be added there, then it's going to be pulled from the environment. Okay? So if we're adding energy to the water, then the environment becomes cooler. Cool. So that ice cube that was in my hand, I needed to get that ice cube to melt. So I was adding energy to it. And as I was adding that energy to it, it was making the environment, which was my hand, a lot colder. Now, what happens if energy is being released? If energy is being released from there, that's going to be negative for my water. That's going to be going whoop, whoop, whoop. It's going to be negative for the water. And what that's going to be doing is it's going to be giving a positive to the environment. So in this case, the environment warms or becomes warmer. Okay? So we have our energy associated with a phase change of water, the actual amount of energy that's there, plus 80 calories from the solid to the liquid. Our sensible heat, yeah. And then latent heat is our 540 calories from our liquid to our vapor. Back the other directions, the same values. And then remembering that when we have our water, whether it's a solid or a liquid or a gas, and the environment, if we're adding energy, latent energy to that water, it's making the environment cooler. It's pulling energy from there. And if that water then is going to be losing energy, it's going to be making my environment a little warmer.